Hi dear students, welcome to this class once again. So already we have started your syllabus in the last class. So that is our first chapter, chemical reactions and equations. Chemical reactions and equations. So try to remember what I told in the last class. So chemical reaction, that means it is a reaction, it is a process in which new substances are formed with new properties. Before this, I clearly explained about the changes happened in your surroundings. They are physical and chemical changes. So, this chemical reaction that involves the chemical changes. If chemical changes happen, there should be chemical reaction taken place. Yes, sir. If the chemical changes happen, there should be chemical reaction taken place. Hence, we say chemical reaction means it is a process in which new substances are formed with a new property. Yes, sir. And I told about the characteristics of this chemical reaction. Characteristics are nothing but what it involves. First one, what it involves? Change in state, change in color, change in temperature, then what? Evolution of gas. Last one is the formation of precipitate. Formation of precipitate. So, if these changes that recognizes the chemical reaction. Understand? That recognizes the chemical reaction. So these are called characteristics of chemical reaction. First ones, once again I repeat that, remember, change in state, change in color, change in temperature, evolution of gas and formation of precipitate. In your textbook they are given only 4 characteristics. Add another one which is that formation of precipitate. Precipitate means what, sir? Are you worried about this? See, precipitate. Precipitate is nothing but white color substance. White color substance formed. The white color substance formed in a chemical reaction that we call it as a precipitate. While writing a chemical reaction, we indicate this precipitate as simply PPT. In a chemical reaction, we indicated this precipitate as only PPT. PPT means, understand, here it PPT means what? Precipitate. Precipitate is a white color substance which is insoluble in water. The white color substance insoluble in water, if it is formed, we call it as a precipitate. Okay. So these are the 5 main characteristics of a chemical reaction: change in color, change in temperature, change in state, evolution of gas and formation of a precipitate. Okay, remember students, these chemical reactions unidirectional, these are unidirectional, that means they are irreversible. Chemical reactions are irreversible, chemical changes are irreversible, but physical changes can be reversible. I will explain with one example. We said physical changes, understand, physical changes are reversible. See, this arrow mark, two-side arrow mark, understand? This two-side arrow mark that indicates a reversible reaction. See example, water is there. Water is there. If you cool the water, this water turns to which state? After cooling, water turns to which state? Solid state, that is ice. That is ice. Just heat this ice. Ice again turns to water. So here only change happened in the state. Properties are not get changed here. Only state can be changed. Water turns into ice after cooling. Ice turns into water after heating. So this is a reversible change. So this change we call as a physical change. These are bidirectional. Is there. One this direction and the one this direction is there. Here we are mentioning this is a with a double arrow mark. With a double arrow mark. If you see the double arrow mark in any reaction, consider it is a reversible reaction. That is a physical change. Understand? But chemical changes are unidirectional. Chemical changes are unidirectional or chemical reactions are unidirectional. Consider. Example is that milk is there. So milk is turns into which? Curd. It turns into curd. Yes or no? Can you change the curd again into milk? Can you get the milk again from this curd? Is it possible? No, it's not possible. Hence it is called unidirectional change. It is an irreversible change. Curd cannot turn again into milk. Hence we call curdling of milk is a chemical reaction and it is an irreversible. Clear or not? Okay. So this is what I explained in the last class. So in this class we will go to learn about the next concept, that is chemical equation. What is that? Chemical equation. Let us come to this. Chemical equation. Already you learned about a chemical reaction. Understand? Coming concept is the chemical equation. So what is this chemical equation, sir? See. So chemical equation means it is a method of representing chemical reaction. It is a method of representing chemical reaction by using their symbols. With the help of symbols and formulas involved in the chemical reaction. Understand? Chemical equation means it's a method of representing chemical reaction with the help of symbols and formula of the substances involved in a chemical reaction. Understand? Okay. In your textbook they are giving one example. Okay. Take a magnesium ribbon and burn it. Okay. Burn it in the presence of air. Finally, what you get? Magnesium oxide. Understand? See. Here, magnesium is the magnesium ribbon. Okay. Burn in presence of air. Sorry. In presence of oxygen. Air means oxygen is there. Burn in presence of air or oxygen. What do you get? Magnesium oxide. Magnesium oxide. So when magnesium ribbon is burst in presence of air or oxygen, what it produces? Magnesium oxide. You will get a magnesium oxide. They said that if you burn the magnesium ribbon in presence of air, it burns with a dazzling white flame. It burns with a dazzling white flame. Dazzling means bright. Understand? When you burn this magnesium in presence of air, they said that it burns with a dazzling white flame. Dazzling means white, very bright. It burns with a very bright white flame. With a bright white flame. Understand? So they use the word dazzling white flame. Understand? So finally, what about the product? Magnesium oxide. Remember, students, already in last class I told about the reactants and products. A reactant means what? The substances which take part in a chemical reaction. They are called reactants. Understand? The substances which are formed in a chemical reaction. The substances which are formed in a chemical reaction, they are called products. So, can you identify here the reactants and products? Magnesium and oxygen, two substances are there which take part in chemical reaction. So these are called reactants. These are called reactants and this is what we call product. This is what we call product. Clear or not? Reactants. See, these reactants in a chemical equation, these reactants write with using plus symbol. What do you call it as a positive symbol, or you can say plus sign. These reactants are write with a plus sign behind this arrow mark. Behind this arrow mark. So what you see, the materials or substances behind this arrow mark, they are said to be reactants. What you see, the substances or compounds in front of this arrow mark. In front of this arrow mark, they are products. Understand? Reactant should be right behind the arrow mark. Product should be right in front of a arrow mark. Clear or not? Reactant should be right with the plus sign. With a plus sign. If the more than one products are formed, it's also written with the plus sign. They are also written with the plus sign. Clear or not? One thing you know, here I am writing only the reactions, the substances which take part in a chemical reaction in there with their names. Magnesium is there, oxygen is there, magnesium oxide is there. So what I told chemical equation means, it is a method of representing chemical reaction with the help of symbols and formulas of a substances involved in it. How many substances are involved in this chemical reaction? Two substances are there. One is magnesium and the one is oxygen. Okay, here magnesium is there. Understand? Here magnesium is there. What is the symbol of this magnesium, you know? Mg. Capital M, small letter G. Capital M, small letter Z. Mg is the symbol of this magnesium. Then oxygen. Oxygen means not only O. Don't write it as a O. Write it as a O2. Write it as a O2. Huh? Why, sir? Why should we write this oxygen anywhere at O2? Huh? Okay. I think you are thinking about this. Okay. Oxygen is always written as O2 in a chemical reaction. That is because this oxygen that existed in the atmosphere in a molecular state, in a dimolecular state. Di means two. It existed in the atmosphere in a dimolecular state. Hence we write this oxygen. Hence this we write oxygen always as a O2 in a chemical equation. Okay. So magnesium reacts with oxygen and forms what? Magnesium oxide. Magnesium oxide. What is the formula of this magnesium oxide? MgO. What it is? MgO. MgO means magnesium oxide. Understand? So what is this? Is a word equation. This is what we call word equation. This is a word equation. This is a symbolic equation. We are writing this chemical equation with the help of their symbol sign formula. Symbol sign formula. Okay. What is the difference between this word equation and this equation, sir? Okay. If you write the chemical equation in the word form, if you write the chemical equation in the word form, you just know what kind of substances are take part in a chemical reaction, but not quantity, but not their quantity. So if you write their chemical reactions with the help of symbols and formulas, you can surely know how many atoms of that elements take part in a chemical reaction. Clear or not? Here I am writing this chemical reaction with the help of symbol and formula. Two reactants are there, magnesium and oxygen. How many atoms are there here? Magnesium, only one is there. Oxygen atoms, two atoms are there. So we know these atoms of that elements are reactants by writing the symbol sign formulas only, but not in a word equation. But we don't know the quantity of that reactants when we write the word equation. When we write the equation in the form of word, we know the quantity of that reactants only when we write the chemical reaction with the help of their symbol sign formulas. Clear or not? So this is what we call, students, chemical equation. This is what we call chemical equation. Clear or not? Okay. I hope you understood this. I will give another example. Take another example. They are given textbook. Okay. Take a zinc granules. What? Zinc granules. Zinc gran. Take a zinc small granules and add a concentrated hydrochloric acid. Okay. So here zinc is there, hydrochloric acid is there, hydrochloric acid is there. Understand? What it forms after reacting together? Zinc chloride. Zinc chloride and releases hydrogen gas. And releases hydrogen gas. In front of that hydrogen, we write the upward arrow. We write upward arrow. See students. While writing a chemical equations, we are using some symbols. In front of, beside of any element or product, if there is a upward arrow mark, that indicates, you know what? Liberation of gas. That indicates liberation of gas. Beside any product or element, if there is upward mark, this upward mark indicates what? Liberation of gas. If there is downward arrow mark beside any element or product, that indicates what? PPT is formed. PPT means already I told, precipitate, insoluble white color substance is formed. That insoluble white color substance we call it is PPT, precipitate. So it is indicated by downward arrow mark. If there is a triangle symbol, this triangle symbol is written on the arrow mark like this. Arrow mark. Here we are heating the magnesium in presence of oxygen. So this triangle symbol or delta symbol, it is also called delta or triangle symbol. This symbol is indicated that these two reactants are heated. So this heating symbol is given by delta or triangle symbol. So what it indicates? Heat. The two reactants are heated. This symbol indicates two reactants are heated. Okay. Next, beneath the reactants, they written like in bracket S. S indicates its state. It's a state. Which state? Solid state. Like this. Magnesium. I write this magnesium in bracket S. In below this oxygen, I write a G. G means it indicates its gas. It's a gaseous state. It's a solid state. If you write the L, if they are written like a L in bracket, it indicates a liquid state like this. They are written in bracket. Solid. This is a liquid. Then this is a gas. Understand? If there is only one direction arrow mark, this is it indicates a irreversible. What indicates? It indicates irreversible reaction. Both side arrow mark, double arrow mark, that indicates reversible reaction. So these are some symbols which are used while writing the chemical equation. Okay, pause this video and try to know once again. Upward arrow mark, liberation of gas. Downward arrow mark, formation of precipitate. Delta triangle symbol indicates heat. S indicates solid, L liquid, G gas. One side arrow mark reversible, two side arrow mark reversible reaction. Clear or not? So this is about what we know, students. Chemical equation. Clear or not? Here I am giving another example here. When zinc reacts with hydrochloric acid, that forms zinc chloride and releases the hydrogen gas. Okay. I write this equation with using the symbol sign formula. See, zinc symbol, you know, Zn is there. Zinc symbol what? Zn. First letter should be capital, second letter should be small. Okay. Don't write like this, okay, this is a wrong method. While writing chemical symbols of elements, first letter should be capital, second letter should be small. Okay. See, hydrochloric acid. Its formula is there H. Okay, capital C and small letter L. HCl, hydrochloric acid is there. And it forms, you know what? Zinc chloride, ZnCl2. ZnCl2. This is zinc chloride and H2 gas. Hydrogen gas is liberated. hydrogen gas is liberated. Okay, so this is another example of this chemical equation. Okay, dear students, I hope you understood this concept, chemical equation. See, once again I repeat it. Chemical equation is nothing but it is a method of representing chemical reaction with the help of symbols and formulas of a substances involved in it. Understand? That's all only. Clear? Okay. In the next classes, we will discuss about balance chemical equations. Balancing of chemical equations is very important concept is there, students. We will discuss about that concept, balancing of chemical equations in a next class. Okay. I hope you understood this concept. Okay. Thank you for watching this class, students.